All right, boys and girls, welcome back to the drive-thru for a special I am here and you're not version of the drive-thru. Hungry? Stop by the drive-thru. Get yourself anything you would like to eat today because I'm starving. Okay, this is Chapter 12, an introduction of functions of several variables. That's 12.1. This really isn't an introduction because we've already talked about these earlier in the year when we talked about the oids. But we are going to revisit our surfaces, okay? Specifically, the surfaces that are graphs of functions of several variables. So, things that we should consider. We're now going to have more than one independent variable. Okay? And we're still going to have one dependent variable. So, let's take a look at an example that seems kind of odd. List the dependent and the independent variables and graph the domain. Graph the domain? What? So let's give you the function first. This is a function of x and y, and it's equal to the square root of x squared plus y squared plus 9 over x. Okay, now, a few things to learn. You remember when you were like so stoked when you guys were like in the second grade and you were like, you're like, oh, that's a line. I understand that now. And then some fool came in and was like, oh, check this out. And it kind of threw you off. You didn't like this. Well, just remember, you could also think of this as z equals, okay? So, that makes x and y are our dependent variables. And then z, which wasn't even listed in the original problem, is our independent variable. Excuse me, I've got that completely backwards. As you can see, x and y are our independent variables, and z is our dependent variable. There we go. Okay? So, that takes care of this. Now we want to graph the domain. Well, why would we ever want to graph a domain? Well, one, it's going to give you an idea of what your graph's going to look like. But two, it's the easiest way sometimes in 3-space for you to describe what your domain is. Okay? You used to be able to describe a domain with a simple less than or equal to sign, or maybe some bracket notation, or maybe even a number line. But here, let's look. X cannot be 0. Okay, and then also the square root of x squared plus y squared plus 9 cannot be negative. So it has to be greater than or equal to 0. Okay, well that's not the best description, and that's not going to necessarily help us graph it that much. So if we squared both sides, we get excuse me, I got this wrong all along. This was supposed to be a minus, and this is a minus. Okay, so we know that x squared plus y squared minus 9 has to be greater than or equal to 0, and we know that x squared plus y squared has to be greater than or equal to 9. Okay, well I recognize this. That's a circle centered at the origin. Okay, and so if we want to graph the domain, and this circle has a radius 3, we're dealing with a circle. X cannot be 0, so we got an open dot at both those spots. Okay, everything on this circle will work. Nothing inside of the circle will work. And then, if I use my highlighter tool, everything on the outside of the circle will work. Practice my coloring. This is fun part of teaching. And there you go. That is the graph of the domain. Okay? Alright, let's try something else that's kind of new. Level curves and contour maps. Sketch a contour map for the following equation of several variables. So f of x comma y is equal to 64 minus x squared minus y squared. Okay. Sketch a contour map. Well, you guys don't even know what contour maps are, so I'll have to kind of walk you through that. But let's get an idea what this function is. That really is, I'm going to come over here. That's a z squared equals 64 minus x squared minus y squared. That's x squared plus y squared plus z squared equals 64. Oh, okay. Now, but it's just the top part of that, so we squared both sides. So this is a hemisphere. It is a hemisphere with a radius of 8. All right, now, I want you to imagine that you're a bug, okay, and you're starting right here, and you're walking up this hemisphere, and you want to get to the top of this half of a ball, this half of a dome. No, a full dome. Okay. So, what would be the hardest part of that route to walk? If you think about the tangent planes, it's definitely going to be hardest at the beginning. And then at the end, it's going to get much easier. How could I describe that? Well, that is what these level curves or contour maps do. So I'm going to walk you through that process right now, and I'm going to do my best to graph this contour map. So what we do for level curves is we pick equally spaced planes, and we shave off our curve at different levels that are equally spaced apart. So if we let z equals 0, we get 0 equals the square root of 64 minus x squared minus y squared. You square both sides, you move some things, you're going to get x squared plus y squared equals 64. So when we intersect it with the plane z equals 0, at z equals 0, we are left with a circle whose radius is 8. Okay? Now, at z equals 1, you're going to get the same thing, 64 minus x squared minus y squared, and you're left with x squared plus y squared equals 63. Okay? So at z equals 1, r is radical 63, like just short of 8. Okay? Well, at z equals 2, r is going to be radical 60, right? At z equals 3, r is, let's see, 64 minus 9, radical 55, right? At z equals 4, so I'm spacing my planes out 1 unit at a time. So you can imagine that like I've sliced this at the origin, and then I've sliced it again here, and then sliced it again there, and then sliced, and I'm taking equal slices. The change in my slice is always equal. Okay, that's the key to making this a contour map or a level curve, because it's going to show us something, and I'm getting at it. So just now, bear with me. Okay, at z equals 4, I'm going to have 64 minus 16, and r is going to be radical 48. At z equals 5, I'm going to have 64 minus 25. I'm going to have r equals radical 39, right? Plus 25. Does that give me 64? Yes. At z equals 6, we're going to have 64 minus 36. I'm going to have 28. At z equals 7, we're going to have 64 minus 49. 64 minus. I'm going to have 15. And then at z equals 8, I'm going to have r equals 0. I'm going to have just a dot there, okay? All right, so remember that one. So now let's sketch these. And let's do our very best to get a good kind of rendition of what's going on here. All right, I got the 8. All right, so at z equals 0, r was 8. I get that curve right there. I'm going to switch back and forth between blue and red. So look, at z equals 1, I got almost the exact same circle. Okay, so the blue line and the red line are very close to each other. And then radical 55, well, that's still more than 7, but it's closer to it. So it's going to be here. And then at z equals 4, I got, oh, did I skip one? Yeah, I did. Okay, I'm going to have another one in there. Well, here, I omitted that one. Now that's going to throw it off. Here, I'll leave it in red. Okay, bear with me. So, these circles are very close to each other as we start. Okay, these are almost the same circle at the beginning. So we've done that one, that one, that one, that one. And now we are on r equals radical 48, so just short of 7. So now we're inside of 7. Okay, oh gosh. And now we want to go just over 6 with the next one. So just over 6. Okay, and then you can see that the distance, I mean just from the calculus, you can see the distance is growing in between these. So now this one's closer to 5. And this one's closer to 4. And then this last one's a point. So somehow I've totally skewed this. But that is an example of what our level curves will look like. Now, if we graph this with technology, it'd be much, much cleaner. But what I want you to observe about this, if I could kind of now use my InterWrite tools and clean that up, here's what it's going to look like. Okay? All right, you got that one. The next one is going to be very close to it, okay? The next one still very close to it, just a little further away, okay? And then the distance in between them starts to kind of grow. So it's going to look something like that. Well, the distance between these curves really matters, okay? And if you remember what we started with, we started talking about a little bug walking up our hemisphere and how it would be most difficult to walk when you started. And then as you got going, it would be easier and easier and easier. Well, the distance between the level curves represents the steepness of increase at that point. Okay, so we're going to close this with a little cross-curricular stuff. Here is a picture of Half Dome at Yosemite. Hopefully you guys are familiar with this. It is your absolute homework in your life to get to this spot. I haven't gotten there with my family yet either. I need to. Alright, so this is Half Dome. You can see right here, that's going to be the video we watch on Alex Honnold about taking risks. This is the flat face of Half Dome. Okay? This just gives you an idea of what the landscape is. Now let's look at this Garmin. This is a level curve for Half Dome. Can you see that right here and right here, these are the most treacherous climbs. This right here would represent, there are so many level curves right here that are right next to each other that the contour map actually goes very, very, very dark. Where here, the contour map is very white. Remember, these are level curves. So what this means is that there's the same amount of vertical increase between this horizontal distance as there is this horizontal distance. So every line that you see represents a constant vertical increase. So the less lines that you see means the greater change in horizontal distance, which means it's much easier to climb there. It's much less slopey, okay? Where here, 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 very, very, very sharp. So take a look at it again. Look, really hard to climb there. Straight up, okay? I didn't mean to zoom. Very hard to climb here. Very hard to climb here. Very hard to climb here. Here, you could walk on this. In fact, that's your reward for climbing Half Dome. You can easily just walk and sit up there. And if you go back to the contour map, that's this. That's this right there. Okay? I hope you guys learned something today. Boom!